Audio. Welcome to Chapter 5. We've now reached tissues. Coming from those individual building blocks of cells, tissues are where all of the cells work together for a common function to help create organs and an organism. Tissues are divided up into 4 main categories. The major types of tissues are epithelial tissues, connective tissues, muscle tissue, and nervous tissue. This chapter is primarily on the epithelial and connective tissue because there are entire chapters later on devoted to the muscle and the nervous system. First, we'll start with epithelial tissue. A general description of epithelial tissue is they are tightly packed cells that reproduce quickly. So if you see tissue that looks like bricks being stacked up and tightly packed together, you're probably looking at epithelial tissue. Epithelial tissue is found covering the outside of the body and lining your body cavities, your lung alveoli, and your kidney tubules. Basically, everywhere that's exposed to the external environment is lined by epithelial tissue. Some characteristics of epithelial tissues are that they are attached to a basement membrane. This means that whenever you see an epithelial cell, it's always going to be standing on a surface. If you were to take a bunch of students and stand them together at the front of the class and tightly pack them shoulder to shoulder, their feet are all standing on the floor. That's what an epithelial cell is doing. It's standing on the floor. For our cells, we call that floor the basement membrane. The reason all of the cells need to be in contact with the basement membrane is that they are avascular. They have few or no blood vessels. Your blood vessels are located below the basement membrane, in the basement, so to speak. And it's through this membrane that the blood vessels' oxygen and glucose is going to travel up into the epithelial cells. So any epithelial cell that wasn't attached to the basement is not going to be getting that good supply of oxygen and glucose. Another characteristic of epithelial cells is you will find nerves traveling through them, providing a lot of sensation. Lastly, they have a high regeneration capacity. This is important because those exposed to the internal environment can get worn down or shed, so we have to replace them with new ones. There are 4 main functions of epithelial cells. First is protection. Epithelial cells protect us against dehydration, abrasion, chemicals, and more. They are also selectively permeable. They act as gatekeepers, controlling which substances enter and leave the body. Example of this is absorption. The epithelial tissue that forms your outer skin is going to control what is allowed to absorb into your body through your skin. Next up, we have secretion. This is the release of glandular substances like tears, sweat, or saliva. That's all done by epithelial cells that form the glands. Lastly, it helps us detect sensations. The rich innervation gives constant info on touch, pressure, temperature, and pain. That's all of those nerves you have running throughout your epithelial tissue are bringing back that information to the brain. Epithelial cells are classified based on the number of cell layers and the cell's shape. When there is only a single layer of epithelial cells, we call that simple. When there are multiple layers, we call it stratified. The pictures on the right here show us a simple epithelium that consists of a single layer of cells, kind of flat and pancake shaped, and stratified epithelium below it shows us probably the skin. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus layers all packed on top of each other. That is called stratified. So that allows us to classify by the number of layers. But what about if our cells are different shapes? Epithelial cells are categorized as either squamous, which is squashed and flat, cuboidal, meaning they're cube-shaped or approximately as tall as they are wide, or columnar, when they are tall like a column. They are taller than they are wide. Form is always there for a function. So each of these different shapes is to allow different processes or absorptions to occur, and maybe it helps to protect us more or to allow for more absorption to happen. It's all dependent on the shape of the cell and the number of layers that are present. This picture shows us the different types that we come across. Simple squamous, stratified squamous, that being one layer of squashed pancake-like cells or multiple layers of the squashed cells. Simple cuboidal, stratified cuboidal, that's one layer of cuboidal cells or multiple layers, in this case 2, of the cuboidal cells. Then we have the columnar. That can be simple, where it's just the one layer. The other option is a little unconventional. It's called pseudostratified. It looks like it's stratified, but in reality, it's just that they're kind of spaced out a little differently so that everyone is still attached to the basement membrane. Did you catch that whenever we have stratified cells, not everybody is on the basement membrane? Remember, I said that epithelial cells are attached to that basement membrane. When we have stratified cells, we start to stack them, and only the bottom is touching the floor. When this happens, because the blood vessels beneath the basement membrane are what are supplying our glucose and our oxygen, that means that as you go up through the layers, if you're in the second layer, you still have some oxygen coming in, but maybe the third still has a little bit of glucose coming in. But once we're getting up into that fourth, fifth, sixth layer, there's not a lot of nutrients, and the cells begin to die. We see that with our skin. The further the cells are in that stack from the basement membrane, the smaller they are, the more shrunken, and eventually they die and just create a layer of dead cells. On to the individual types. Where are they found and what are they used for? Simple squamous is adapted for diffusion and filtration. Simple means it's a single layer. Squamous means it's flat like a pancake. So this microscope slide shows how it looks looking down on them from above, almost like paving stones all squished together. Because these cells are so thin, creating just barely a layer of cells, they are perfect for diffusion and filtration. Substances are going to easily be able to travel through a single layer of a squamous cell. Because of that, we're going to place them in locations where we want something to cross the cell membrane and diffuse into or out of the body. We find these in our kidneys, our lungs, and lining our blood vessels. Being so thin, they allow oxygen to diffuse across the cell into your blood vessels. We also line our blood vessels in the body, and it allows that oxygen to come out of the blood vessels into the surrounding tissue. Thus, the function of it is based on its form, the fact that it's so flat. Maybe we want to have some absorption and diffusion, but make it a little more difficult. Maybe we don't want as much to absorb back through it. Let's use simple cuboidal then. They're still a single layer, but they're a little bit thicker than the squamous, so they're going to have more control over what comes in and out. We find these in our kidney tubules. Simple columnar is a single layer of column-shaped cells. These are there to absorb nutrients and to secrete mucus. We find them in the small intestine and the uterus. On to the stratified cells. Here's stratified squamous. Because we're no longer that single layer, instead we have begun to stack those cells on top of one another, we're not here for diffusion and absorption. That's not our goal. We are here for protection. We find these cells lining our body cavities, our skin surface, and also inside of our mouth. These cells are perfect because as we provide nutrients to the bottom layer where the regeneration happens, new cells are constantly being produced and are being pushed upward towards the surface. As they travel and get farther away from the nutrient-rich basement membrane, they begin to get smaller, to shrink, and to die, and by the time we get to the top, they are now dead and easily shed. But this layering of dead cells is very good for protection because any bacteria that got onto that surface is going to have a very difficult time getting through all of those layers of cells down through the basement membrane. Now we're going to spend a whole lot of time on skin in our next chapter, so we'll have to move on and save most of that for next week. Here we have stratified cuboidal. Stratified cuboidal is typically seen in 2 layers, and it's mostly cuboidal shaped. I mean, it's about as tall as it is wide, so don't be thrown off if you see one that looks a little more rounded. It's still cuboidal. Because they are stratified, we're not trying to absorb with these cells. We're mainly using them for protection and secretion. We see these a lot in our kidneys. Now, there are in fact stratified columnar cells, but they're very rare. We only see them in 2 places, in the male urethra and inside of our salivary gland ducts. Much more common are the pseudostratified columnar. These guys are forming a single layer, but it's deceptive because it looks like they're stratified. They are taller than they are wide, forming those nice columns, and they are performing secretion and cilia movement. We find them in the air passages and the reproductive system. These cells are specialized to produce mucus, and when they do, they can put that onto their surface and it'll trap any foreign particles that come in whenever you're breathing, for example, and it'll use the cilia to push them back up out of the lungs. So these mucus-producing cells are very important. Lastly, we have the transitional cells. These cells are in multiple layers and they do not have a standard shape. The function of transitional cells is to stretch. The cells are kind of a round shape when they're relaxed, and they become flat, almost squamous-like whenever they're stretched. You'll find these inside of the bladder. Lining the bladder walls, they do not want to absorb. We work really hard to produce urine, and we put it inside of the bladder, and we do not want that coming back into the body. So the multiple layer that you see in the transitional, part of that is it is not going to absorb any of that urine back into the body. We just need that stretching because a bladder that's empty might be smaller than the size of your fist, but a stretched one can hold up to a liter of urine. The cells we've just seen are all membranous epithelial. It's always had one surface exposed to a body cavity, a lumen, that is like the opening through the intestines, or the skin surface. There's another type, though, that's called glandular epithelial. These cells are specialized to secrete. If you notice in the picture, they did have that surface that was exposed, but it began to curve inward and come down, forming a structure that is made up of epithelial cells, but it created its own little space inside. These are called glands. They are individual cells or multicellular organs made of epithelial tissues that secrete substances. Glands are classified by their method of excretion. Exocrine glands secrete externally onto the surface. Endocrine glands secrete internally into the bloodstream. Now keep in mind that surface might be the surface of your skin or it might be the lumen of the intestines. Here's a picture of an exocrine gland. This one is going to secrete onto the surface. It produces sweat and secretes it onto the surface of the skin. Breast milk is another example. It's actually produced by these exocrine glands as well. It's just very nutrient rich with fats and lipids and antibodies to keep those babies healthy. These pink cells up at the top of the bloodstream are the endocrine glands. They are going to secrete their hormones directly into the bloodstream where they travel down to other cells. Obviously, the method is very different. One, the exocrine glands are producing that substance that they secrete onto the surface, and the endocrine glands are secreting something that travels through the bloodstream. Exocrine glands have ducts and secrete to the exterior, but there are 3 different methods used to produce secretions. The first one is the one where if I was a gland, I would want to be. These glands export their secretions without damaging the cells of the gland. Next up, there are glands that fill the cells with secretions and then export those and send those out. Lastly, there's one that actually destroys the cells in the process, and that one we have to regenerate constantly to keep up our numbers. Let's look at those 3 and give them names. Here is the neurocrine gland. The neurocrine gland packages secretions in vesicles and releases them. No damage is done to the glandular cells. Because of that, we don't have to regenerate them. They're good to go. We see the salivary glands in this example. The next one is the apocrine gland. In this gland, the cells themselves are pinched off and secreted. The gland repairs the damage by producing more cells. Mammary glands work this way. That breast milk is actually part of those cells that is pinched off and then exported. Then we have the holocrine gland. Holocrine glands work by having their cells accumulate the secretions inside of them, and then they burst, and all of those cell remnants are pushed out of the gland. A good example of this is the glands that coat your hair in oil. That oil is going to be produced by the cells filling themselves up with oil and then rupturing and bursting, and all of those contents then come out and smear over your hair and give it a nice oily appearance. Interesting. Anybody want to go shampoo their hair real quick? Nice. We finished up the epithelial tissue. How about a picture to put it all into perspective? It shows what those cells are doing inside of his body right now. They're pretty busy.